All right, listen up. We're going to solve quadratics by taking the square root. And that's exactly what it sounds like. The way we solve this is we have to take the square root, right? Totally different what we did with factoring. And then our future lessons, we are solving it by taking the square root. So quick warm-up problem, solving this linear equation. Okay, so how do we solve this? We add 10 to both sides. We get 5a equals 220. We divide by 5. And so we get a is equal to 44. Cool beans. So we're going to remember that. Keep the back of your mind. Boom, boom. That's our goals, right? When solving to take the square root, we are going to have to do some algebra 1 manipulation. So just keep remembering that. All right, cool. So here we go. We're solving by taking the square root. That is the lesson. So that is the activity or the process that you have to do to solve this. So I get x squared equals 9. Now I'm going to go to the past for a second. In our past, we would subtract 9 on both sides because we would want it to equal 0. And then what would we do? We would factor. And so we get x and x, 1 and 3, or 1 and 9, 3 and 3. So we choose our factors, x minus 3, x plus 3. Set each factor equal to 0 because we are solving. And solve, so we get x equals 3 and x equals negative 3. What would that look like graphically? Right? Graphically, we would say, okay, y is equal to x squared minus 9. I would add 9 to both sides, so y plus 9 is equal to x squared. I would make my table. And so I'm going to just pick 2 points, so our x and our y. My table will be negative 1, 0, 1, and I have 1, 0, 1. And I'm going to subtract 9 from all the y values. And so when I go to graph this, I'm going to have, just had a brain fart. I'm going to have negative 1, negative 8, right? And then I could go and graph this. And when I go to graph it, what I do realize is that if I was to keep going, I would have a point here at negative 3 and point here at 3. My y-intercept is at negative 0, negative 9, and I will graph this, okay? So why am I doing all this? Why am I showing you this? I want you to recognize that we end up getting, for this equation, whether we graphed it, whether we solved it by factoring, or we graphed it, we end up getting these x-intercepts as x equals negative 3 and positive 3, right? That's a big deal for us, okay? And so why is that? So let me erase this because we're not solving this method. We are solving by taking the square root. That is the main concept here. And we get x in the square root of 9 is 3. But when we're talking about quadratics, we have to remember that we're talking about the fact that they go into 2 sides of our equal signs, right? When we go to factor, we get 2 types of solutions. We get these 2 pieces here. So it's not just 3. It's positive 3. It's also negative 3. Now, you're like, whoa, why'd you write it like this? For us, the mathematicians, the further we go, we want to write as least amount of stuff as possible. So instead of writing x equals 3 like here and x equals negative 3, we can just put positive, negative 3. And what that means is both the positive version and the negative version. Okay, dokie. So that's the new concept that you're going to learn today. It is not like when you're doing like Pythagorean theorem back in geometry where you're like a squared plus b squared equals c squared and you solve. And you say just 3 because you don't have a negative distance. That's why we keep the positive. Right here, we are talking about the negative distance. We're talking about the distance it is from the x-intercept here or any of those transformations that happen, right? So we do want the positive and the negative. So that's going to be the first big takeaway here. So when we go to take the square root, I need to see positive and negative answer. I need to see that that is part of your solution. If you don't put it, you'll get it marked wrong. For those of you who are doing Get More Math with me, Get More Math, you're going to put your answer as 3, negative 3, or you can do negative 3, 3, doesn't matter, but they do want you to separate your answers, okay? But I need you to practice both versions for taking a test, for answering your sheets, whatever it is that you know how to solve it in both ways. Cool beans. So this is the why, not necessarily for you to write this down, but if you did, even better. But this is why we get those two solutions, okay? So we're not going to do that for all the rest of these problems. That's not going to work for us. We already solved that one way. So again, how do we solve this? We take the square root of both sides, and I get x is equal to, because the square root of x squared is just x. Those two things are inverses that cancel each other out. Okay, it's the equivalent how we divide by 5 to get rid of that 5 there. That's what that is. It's just inverses. Okie dokie. And so now what do? We're going to factor 45, and that's what, 9 and 5, and that's 3 and 3. Okay, if you remember anything from factoring, right, we have this 3 times 3 times 5. They're all inside the radical together. Well, if I want to, I can take these pairs out. I do want to, actually. I want to take these pairs out, and it gets as written as one pair, right? And then the one that did not get paired up, it is now a 5, and it stays inside the radical. And then we are going to put our plus or minus attached to that. Okay, another way to look at this, right? Again, we go back to the 9 and 5. This is the square root of 9, and this times 5, right? What's the square root of 9? It's just 3. Do we know the square root of 5? We do not, so we leave it on the radical. So multiple ways to go about this. If you have any questions, please don't hesitate to contact me. All right, and then last but not least, we have b squared equals negative 48. So again, how do we solve this? Well, whoa, this is negative. Does that change things? Okay, well, let's talk about it. I'll take the square root, just like we were going to do before. I'm going to factor this. It's going to be 7 and 14. Okay, I'm going to ignore the negative for now. And I'm going to keep factoring 7 and 2, right? I like to bring my stuff down to the same level so they're all together. These are pairs, and so that would go out, and then square root 2. Okay, so then what do I do with that negative? Do I put a negative here? Well, no, because just to go back to this example, negative 3 times negative 3 is positive 9. So it can't be a negative there, okay? So let's try something else. Do I keep the negative inside? We could, but that's weird. We actually find that to be a little strange. So instead of writing the negative inside, what we're going to do is we're going to put an I. And that lets us know that we took the square root of a negative number. This is called an imaginary number. Now, here's the deal. We are not going to go into details just yet on what an imaginary number is. What I need you to understand is that when I see a negative, and I'm taking the square root of a negative number, throw an I on there. And I promise you later on we will cover exactly what that means, okay? And that last but not least, we need to put in our plus or minus. Now, I want to go over get more math for these two problems. For this problem, when you're going to get more math, you're going to put 3 square root 5, comma, negative 3 square root 5. That is how you answer this and get more math. Okay, so anything that's in green, I'm showing you how to put in your get more math ahead of time. And then over here, for get more math, it doesn't recognize imaginary numbers just yet. So what we're going to put is no real solution. Because with that imaginary, it is it's an imaginary number. Now, not like a fake number. They are real. We can do operations with them, all that type of stuff. We'll talk about it in more details later. But it's not a real solution. It's not a real number. So no real solutions. Okay. And so that's what it's going to look like. You can get more math. You're going to find that button. You're going to click that anytime I have to take the square root of a negative number. Okie dokie. All right, and then we get to the next section, these 3 problems here. These problems are just all about solving. When we go to solve by taking the square root, we're going to do exactly what we did with the warm-up by solving this for our variable. And then our last step is going to be taking the square root. So here you go. We're going to knock these out real fast. How do I solve x squared plus 6 equals 47? I subtract by 6. I get x squared equals 41. I take the square root. And I get x equals, I'm going to put my plus or minus. Got to always have that there. And then 41. Well, 4 plus 1 is 5. It's not divisible by 3 nor 9. It's not even. Can it be divisible by 7? Let's see, we have 28, 35, 42. It's just a little bit short of being divisible by 7. This is a prime number, so we leave it in the radical like it is. Cool. Moving on. How do we solve this one? Maybe. Oh, no. Okay. Sweet. Okay, so square root 41. How do we solve this one? We're going to add 2 to both sides. And we get p squared is equal to -4. I wanted to put this back in black. Sorry. Picky me. Okay. And then now we go ahead and take the square root. And so we get p is equal to, I need my plus or minus because, you know, it's a square root. And then the square root of 4 is 2. I know that part. So I'm going to go ahead and put my 2. But it says the square root of a -4, so then I throw in that I. But remember, for Get More Math, you will put no real solution. Okay. And last on this section. Okay, this problem looks like it's going to be complicated. We're going to divide by 25. You're like, oh no, that's going to leave me a fraction. That's okay. Leave it as a fraction. So what do we get? X squared is equal to 16 over 25. What do we do to solve it? We take the square root. So we get x is equal to, of course, we need our plus or minus, right? Because we have the positive and negative version of these numbers. And then the square root of 16, well, that's just 4. And the square root of 25, that's just 5. That's it. Don't overthink those, right? We're just taking the square root of each numbers. Last 3. All right, so what I'm going to do is I'm going to pause my screen. Oh, I'm going to do the first one. So again, we're just solving. This is nothing more than a solving equation. Also, can we change this problem to look like that? So -49b squared plus 5 equals -44. So I'm going to change that problem. Okay, so we're just solving like a two-step equation. We're going to add 9 to both sides because those are inverse operations of each other. So 5k squared is equal to -50. We are going to divide by 5, because that's the inverse operation of multiplying by 5. And now we're on taking the square root. Same process. You just have to know how to solve a linear equation. So k is equal to plus or minus, because we took the square root. I see a negative, so I'm going to throw an I. And then the square root of 10 stays the way it is, because it is a prime number. Now, notice some placements about my I. I always like my I's in front of the radical. Okay, so my I goes in front of the radical, but behind my integer. Okay, it goes behind my integer, but always in front of the radical. I love the placement that way. It makes it clear of what we got going on. It doesn't look like that I is underneath the square root, so just clear everything up. All right, I'm going to have you guys pause your screen, and hopefully you can solve these two. Put the answer up, and if you got them wrong, just communicate with me, and we can talk about it. Okay, so there's the 2 answers. Let me know how you did. If you have any questions or comments, hit me up. You can start your work on Get More Math, and I'll talk to you later. All right, bye.